You think that's air you're breathing now?
One of the newest developments is that nanoparticulate matter can be stabilized for distribution. If you're not aware what nanoparticulate matter is, it's that matter which exists on a scale of 1 × 10⁻⁹. Very, very small. Smaller than a cell. And we can manufacture materials that have discrete properties that can be controlled by virtue of bioengineering and their physical chemistry. To auto-aggregate, to be able to aggregate in particular areas based upon their biological and or chemical sensitivity. But now we go one step further. Most recently, just a few weeks ago, it was announced that you could then aerosolize nanomaterials. And go one step further, I can create small robotic units, controllable robotic units at the nanoscale, and that these too can be aerosolized to create a nanoswarm of biopenetrable materials that you cannot see, that can penetrate all but the most robust biochemical filters, that are able to integrate themselves through a variety of membranes, mucous membranes, and wherever, mouth, nose, ears, eyes, can be then uptaken into the vascular system to create clumping, can affect the vascular system of the brain, or can directly diffuse into the brain space, and these can be weaponized. And they can be done in such a level that their presence is almost impossible to detect, and as such, the attribution becomes exceedingly difficult to demonstrate. How much of this material would I need? Take a look. This is the front of my pen. This amount of nanomaterial, if be able to maintain and sustain with regard to its deliverability and aerosolization, could in fact affect all of you, or based upon where I come from, New York City, all yous. Look at this. Look at this. I'm carrying that material. Would you see it? Would I have to lug a giant weapon into the room? No, I wouldn't. And what if, in fact, I utilized some form of an unmanned aerial device or unmanned ground device as a delivery vehicle? Something like a drone or a bug. Could I do something with that?
Yeah, later, huh?
Right, later. Just after we
Okay, this is a real rock.
I got something to say. I want to know how come the fascist pigs have been seeding the clouds.
Right, for the last hour and a half.
Airplanes going over twice with all the smoke coming out of them seeding the clouds. And I want to know, why that stuff is going down, man. And why doesn't the media report that stuff to the people, man? I'm telling you what happened. The planes come over
for an hour and a half
and they
during the
seeded all
concert
the
at
clouds.
Woodstock.
It's the second time they did
People
this
of
today.
unknown origin were seeding the clouds over the
I don't know what they hope to prove, man.
What's going on here?
We're here in Santa Barbara County, home to one of the longest running cloud seeding operations in the country. We've got some ground-based cloud seeding equipment right here, and we're gonna get to hear all about how it works and see it in action. Let's check it out. Cloud seeding is the most common type of weather modification, and it has many different techniques and applications. Today, it's mostly used to increase rain and snowfall, reduce the size of hail, and reduce fog at airports.
Traditionally, cloud seeding has been done from the air. So airplanes have had racks on them where these same flares are positioned on the airplane, and the airplane flies into the storm. So in order to reduce the cost to the client and reduce our carbon footprint, we've been able to station these on the ground. So these are referred to as AHOGs. That stands for Automated High Output Ground Seeding Systems. We've got 3 primary components of our equipment here. The first is the control module that you see behind me. Then we have our actual cloud seeding flares. The camera is for security. It also helps us observe weather conditions in real time and make sure that all of the equipment is operating correctly during a storm. Inside these canisters are the flares with the seeding agents. The canisters are used as spark arresters, so they prevent sparks from reaching the ground. So if we pull off the spark arrestor, you can see the flare inside. The ignition of the flares are controlled from the control module that's behind us. So the white triangle there is a cell service modem, and then the solar panel keeps us powered. Inside we have a battery and then a control board. So the control board interacts with the software. We're linked or synced with the software in Utah currently, and that allows us to fire or ignite any of the flares from that remote location. The primary seeding agent in this is silver iodide. Silver iodide is a simple compound. It's polar in nature like water, so there's chemical properties that help attract water molecules to silver iodide. It's also structured molecularly similar to ice. So it helps generate or helps spawn the generation of ice buildup, and then that becomes a hailstone or a snowflake that falls here primarily as rain. So one flare like this has billions and billions of potential sites for that water to congregate around. We'll launch them in sequences. We watch the radar to see when bands of the highest concentration of liquid water are passing above us in the clouds, and we try to target those high concentration pockets in the storm systems. We'll launch between 3 and 20 flares for a typical storm. Once the flare is lit, it takes a little bit of time to carry up into the clouds, and once it's up at the proper elevation, it'll take about 20 minutes to instigate the rain or the snow process. So overall, you're probably looking at about 40 to 45 minutes before you're seeing the maximum result. One of the biggest questions, or most common questions that we receive, relates to the safety of silver iodide. Silver is biologically inert, so it will not interact in a negative fashion with plant or animal life. Iodine is actually a critical building block of a number of hormones in animals, so it is safe as well. In fact, if you look at table salt or baby formula, you'll see iodine in its molecular form as an additive in those commonly consumed substances.
Since the 1946 experiments of Dr. Vincent Schaefer, we have known that some clouds can be modified through seeding to yield additional precipitation.
Since the 1940s, people have been seeding clouds and watching the effects with their own eyes. But there's always been something missing: the cold, hard scientific evidence to back it up. That changed recently. In 2017, the National Science Foundation funded a study to determine cloud seeding's effectiveness once and for all. Weather Modification International provided the planes. A team of scientists set out into the Idaho mountains with Doppler radars and state-of-the-art weather stations to record what happens on the ground when planes above are cloud seeding.
And what did you guys find?
The aircraft flies through that, and you can see the ice crystals grow right on the radar, and you can see the snow showers form, and as they pass over the mountain, you can see the snow very visually and conclusively is produced from the cloud seeding aircraft that just flew through that particular cloud and system.
Radar images show how ice crystals formed in the clouds in the exact pattern that Weather Modification's pilots were flying. The long-awaited scientific proof that cloud seeding was working had finally arrived.
The UAE is one of the driest countries on Earth, with an annual rainfall of roughly 120 millimeters. As a result, it has to get creative when it comes to finding solutions for water. In the early 2000s, the UAE started performing regular cloud seeding operations. Cloud seeding is the process of increasing the amount of rain produced from clouds.
Some of these clouds, by nature, sometimes it rains, for example, only 40 to 50% of its rain that processed in the cloud that comes as rainfall. So by these operations, we try to increase this amount by, for example, from 15 to 30%.
So how does it work? It starts here, inside the National Center of Meteorology, where a team is constantly monitoring forecasts, looking for potential clouds to seed. The operations only work with cumulus clouds, which are vertical in shape.
Research 5 operation, can you read me?
Once they spot a cloud, they radio the pilots, who then take to the air armed with hydroscopic flares filled with a mixture of potassium chloride, sodium chloride, magnesium, and other materials. In 2017, the UAE performed 242 cloud seeding operations. The government is confident the operations are increasing the amount of rainfall, but it's difficult to gauge.
Until now, there is no way that you can measure the success rate for each individual cloud. There are no two clouds are the same, and you don't know, for example, before actually you see the cloud, is it going to rain by itself or not, and by how much?